everybody, in this video we're going to talk about how to add and subtract fractions. So let's start with an easy example where we have common denominators. So if I want to do 3/5 plus 1/5, there's several different ways that I can model this. One of them is a region model. So with a region model, I could have a circle or any shape that I wanted to use split up into 5 equal pieces where 3 of them are shaded, and that would represent the fraction 3/5. And then I could have another circle split up into 5 pieces where 1 of them is shaded, and that would represent the fraction 1/5. And if I combine these two amounts together, I'll get the fraction 4/5. And the reason why the denominator doesn't change is because the denominator determines how big the pieces are. So in this case, we have a denominator of 5, and that tells me that there's 5 equal pieces in each whole. And so essentially that's telling me how big the pieces are. Because if it was a number like 8 instead of 5, then my pieces would be smaller because I would have 8 pieces in a whole instead of 5 pieces. So the denominator stays the same because we're not changing the size of the slices. And when you add 3 of those slices to one slice, that gives you a total of 4 of those slices that are of size 5. You could also model this on a number line. So if I take the distance between 0 and 1 and split it up into 5 equal sized pieces, the way that I could draw 3/5 plus 1/5 is I would go forward 3/5. So here's 1, 2, 3. And then since I'm adding on 1/5, I would add 1 more. And that takes me to the mark on the number line that represents 4/5. You could also do this with fraction strips. So fraction strips are very, very similar to the number line model. Just instead of drawing out a number line, you would use the little fraction strip blocks. So you'd find the blocks for the 1/5 amount, and you would have 3 of them lined up to represent 3/5. And then you would combine that together with another one that represents 1/5. And when you combine all of them together, you would have 4/5. And when you're teaching this to your students, it's really important that you show them a visualization, and the more visualizations, the better, because a common misconception that students will often make when they're adding fractions, if you don't show them the visualization, is they'll say that 3/5 plus 1/5 equals 4/10. And if you show them it visually, it's really easy to show why this answer does not make any sense. Because if you were to draw a picture of 4/10, you'd have a circle that's split up into 10 pieces. Let's see if I can make it like this. And you would have 4 of them shaded. And when you draw a picture of it, it's really obvious that this circle plus this circle could not equal this one. But conceptually, they may make that mistake if you don't show them a visualization of it. So that's how you add fractions, and the process for subtracting fractions is very similar. So if I had 7/9 and I wanted to subtract 2/9, well, one way you could represent this with a region model is you could have a circle split up into 9 pieces, 7 of them are shaded, and then we would take away 2 of them, which means that we have 5 left. And so 7/9 minus 2/9 would give us the answer 5/9. You could also show this on a number line if we split the distance between 0 and 1 into 9 pieces. So here's 1, 2, 3, 4, 5, 6, 7, 8, and then 9/9 would be where the 1 is. So if I wanted to model 7/9, I'd go forward 1, 2, 3, 4, 5, 6, 7/9. And then if I want to subtract 2/9, I would just go backwards 2/9, and that would take me to the mark that represents the amount 5/9. So that's how we would represent it with a region model and a number line. You could also represent it with fraction strips if you laid together 7/9 and then took 2 of them away. And that's how you would subtract fractions with common denominators. But sometimes when we're adding and subtracting fractions together, we don't have common denominators. Like, for example, if we have 1/5 plus 2/3 and we visualize that with a region model, well, the 1/5 green slice of the circle is much smaller than the 2 blue slices that represent 2/3. And so in order to combine these together, we need to make it so that all of the pieces are the same size. And the way we do this is by making the pieces smaller. So when you're adding two fractions together that have different denominators, you can multiply the top and bottom of the fraction by the opposite denominator. So for example, I could do 5 times 3 and 1 times 3, which basically means that I'm splitting each of my fifths into 3 smaller pieces. And so it would look kind of like this. And that means that 1/5 equals 3/15, because when I split each of the 5 pieces into 3 smaller pieces, I now have 15 pieces total. And the one piece that was shaded before is now 3 of those little pieces. Then I could do something similar for the 2/3, except instead of multiplying by 3, I'm going to multiply by the opposite denominator, which was the number 5. And basically what that's doing is it's splitting each one of these thirds up into 5 equal-sized pieces. So if I do that and I write that out, then the number of pieces that I have total is 15. And the 2 pieces that were shaded before are now 10 of these little pieces. And once I do that, then I can say, okay, well, 3/15 plus 10/15, now that they're all the same size of pieces, I can just add them together, and that gives me the fraction 13/15. So the way that you add fractions that have uncommon denominators is you basically make it so that they do have common denominators by finding equivalent fractions. You could also model this on a number line. So if I had 1/5, I would basically have my number line split up into 5 equal pieces, and my 1/5 mark would be up to this point. And then if I want to add 2/3, well, my number line isn't split up into thirds. And so what I would want to do instead is I would want to say, okay, well, I know that 2/3 equals 10/15. So if I split up my fifths into thirds, so like this, and I'll just go ahead and split this one up as well. That tells me that these little red marks represent the 15th marks. And so instead of adding 2/3, I can add 10/15, and I can say, okay, well, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that puts me at the mark that represents 13/15. And you could also think about it and say, okay, well, how many 15ths is in 1/3? And that would be 5. So you could also think about it as going like this. And that would be the same thing as adding 2/3. So in my opinion, with the uncommon denominators, it's much easier to visualize it with a region model than with a number line model. But you can represent it with a number line model if you'd like to. So the process for subtracting fractions with uncommon denominators is very similar. Just instead of adding the top numbers together after you find common denominators, you'll subtract them. So in this case, I could say, okay, well, I'm going to do 8 times 2 and 5 times 2, which tells me that 5/8 equals 10/16. Then I'm going to do 2 times 8 and 1 times 8, which tells me that 1/2 equals 8/16. And then I'm going to subtract those, and that gives me the answer 2/16. And if I wanted to write this in simplest form, I would divide the top and the bottom by 2 because they have a common factor of 2. And that would give me the answer 1/8. So this is what my answer would be. And there is actually an easier way in this problem to solve this. So you can just multiply by the opposite denominator, and that totally works. But if you want to, you can make it easier to reduce later if you find the least common denominator. So the least common denominator is the least common multiple of the two denominators. So if I were to list out the multiples of 8, I would have 8, 16, 24, etc. And the multiples of 2 are 2, 4, 6, 8, 10, etc. And the least common multiple in this case is the number 8. So instead of multiplying by the opposite denominator, I could multiply by whatever I need to in order to make it so that the fractions have a denominator of 8, because that's the least common multiple of the two numbers. So in this case, I would say, well, 5/8 already has a denominator of 8, so that would just be 5/8. And to make 1/2 have a denominator of 8, I would multiply the top and the bottom by 4, which would give me 4/8. And when you subtract this, 5/8 minus 4/8 equals 1/8. And notice that we didn't need to reduce in this case because the denominator was a simpler denominator than the one that we found above. So when you're finding common denominators, you can either multiply by the opposite denominator to create your common denominators, like we did here when we found a common denominator of 16, or you can find the least common multiple and find equivalent fractions that way. And technically, this is not the only way you can do it, because there's an infinite number of common denominators you could use. Like, for example, maybe you could do the common denominator of 80, and you would have 50 over 80, because if you multiply the top and bottom of 5/8 by 10, you get 50/80ths. And then 1/2 in terms of 80ths would be 40/80ths. And when you subtract that, that would give you 10/80ths. And when you reduce that by dividing the top and bottom by 10, you'd get 1/8. So that would be another common denominator you could use. And there's an infinite number of them because there's an infinite number of common multiples. But if you find the least common multiple, then it will be the easiest to reduce your answer. So when you're adding fractions together, the properties that we learned for whole number addition still apply. So we have the closure property, which says that the sum of two fractions is a fraction. We have the commutative property, which says that you can rearrange the order of adding up the fractions and the answer will still be the same. We have the associative property that says it doesn't matter which fractions you add together first, the answer will still be the same. And then we have the identity property that says any fraction plus 0 equals that same fraction. So as you guys are working on your homework, you can use these properties to make some of the addition problems simpler. Like, for example, if you had 1/8 plus 2/3 plus 7/8, you may want to use the commutative property and switch the order of these two and think of it as 1/8 plus 7/8 plus 2/3, because 1/8 plus 7/8 is 8/8, which is a whole number. It's the number 1. And so this would just equal 1 2/3. And so that would make it so you don't even have to find common denominators between 3 and 8, because these two fractions added together to be a whole number. So if you want to use those properties to make your homework easier, you're welcome to do that. And if you have any questions, let me know.